Hello, math students. Today our review is going to be about area. The next chapter we're going into uses area. I'm going to go a step beyond that, but we need to refresh your memory on some formulas that we have, and you should have a formula sheet handy that we already gave you. In these two shapes, the first one's a square, the second one's a rectangle. The only difference is that in a square, we have all the sides that are the same length. In a rectangle, the opposite sides are the same length. These aren't marked with right angles, but you guys know in a square or in a rectangle, we would have right angles in everything. The area of a square and the area of a rectangle is basically the same. For the rectangle, I'm going to do that one first. The area formula that we would use, and this is right on your sheet, can either be written as length times width, like we've got it here, or base times height. Doesn't matter. The parallelogram has base times height on your sheet. The rectangle has length times width. They are the same thing. So it doesn't matter to me. I personally prefer base times height, but you can have area equals length times width. Just be careful when you write your L for length that it's lowercase, first of all, because it's the capital letters are for the formulas, and that it doesn't look like a 1. Okay? The reason I started with that one is because for the square, I could use the same thing, but I can be a little bit more specific for a square. For a square, instead of saying base times height or length times width, the numbers are the same. So in a square, my formula, and you might want to add this to your note sheet, even though you probably already know this, sometimes we'll write this as a side length squared because we'll have the same number in both places for length and width or base and height. Okay, so I don't really care if you use the same formula that you had for the rectangle because a square is just a more specific kind of a rectangle. So for instance, in this problem in this first picture, I would have that the area is going to be, I'm going to use my formula here, 5 squared. It's 5 times 5 because the base is 5, the height is 5. So that is going to be 25 square centimeters. When we label these, area is a squared unit. Square centimeters, square inches, square feet, square miles, square kilometers, whatever label you happen to have, it's two-dimensional because we can measure a length and a width or a base and a height. 2 dimensions means I get a squared label. For the rectangle problem, I don't necessarily need you when you do your own problems to do the work inside the shape. It just works out better the way that I've got it on the board right now. The base or the length would be 8, and the height or the width would be 3. So this is going to give me 24 square centimeters. And it should be read as square centimeters, not centimeters squared. I know that it looks like you should say the centimeters first and then the squared. It's just how we read that. These two shapes are both parallelograms. And the formula for the parallelograms, and by the way, parallelograms just means that the opposite sides are parallel. So the top and the bottom are parallel, and the two, these are both kind of facing the same way. So the slanted sides are both parallel as well. I'm going to start again with the second problem because I think it's a little bit easier to see what's happening here. So this area, according to our formula sheet, is base times height. Right? Either you can have the dot there, you can just smush them together. Please don't use an X. I'm going to have the base on this one is 15. Now you guys know that if this side is 15, this side is also 15, right? The base and the height just have to make right angles. So that's why I can't use the two sides on the left and the right because that doesn't have a right angle measurement with anything. It's not that I couldn't get that, but I don't have that right now. So 15 is the base. The height is this 8. And again, this right angle right here is what tells me for sure that it's the height. So I would have 15 times 8. Now, this is an excellent review today and in the next unit to have a calculator handy. Please, please, please have a calculator handy. This is going to be, the area is going to be 15 times 8, which is 120 square inches. Now, the first picture on this slide, has this 7.7 centimeters on the outside. I hope that you can see that what they have measured there for that 7.7 is the same as this length right here, which would also be 7.7. Sometimes when we have something like a parallelogram that has that slanted kind of a side, they want to do what's called dropping in altitude. They want to have this dashed line over here showing that that's the height. Notice the right angle. That tells me that it would be perpendicular. That's another word that I hope that you already know. Perpendicular to the base. But this is still just going to be base times the height. So this would be 8.8. I'm going to do this one down here, I guess. 8.8. I'm going to use parentheses here instead of a dot because of the decimal. And the height is 7.7. And again, great place for a calculator. So we have 8.8 times 7.7 gives me 67.76. Now, this was measured in centimeters, so it would be square centimeters. If you have two decimals, if you have multiple decimals, as long as they stop, I would not round unless they tell you to. Don't change this into 68. Don't even change it into 67.8. I would like, especially since it's exactly two decimal places, just leave it exactly the way it is on your calculator. If they tell you to round to the nearest tenth, for instance, one decimal place, then you might have to. These two are both triangles. This time we're going to start on the left. This is a right triangle. The formula for a triangle, again, from your formula sheet, is 1/2 times base times height. Okay, so the base times height part you should recognize because that was for a rectangle or for a parallelogram. However, a triangle is just half of a rectangle or a parallelogram. And it's easy to see that in a right triangle, for instance. So if I would do this, these two triangles, I know I didn't draw it perfectly, but those two should be the same size. They would both have the exact same base, and these two sides would match. It's a rectangle. So I would need half of that rectangle. That's why my formula is area equals 1/2 base times height. So I would, in this one, just write down everything in order. 1/2, the base is 6, the height is 7. Now, in theory, we should be multiplying in order from left to right because that's what order of operations tells us. However, there's also a rule for multiplication and for addition. If you only have multiplication or if you only have addition, you can multiply it any order you want. This one, I probably would do this exactly the way it is because I could do 1/2 times 6 in my head and get 3. 3 times 7 is going to be 21. And this was in inches, so square inches. If you had multiplied the 6 times 7 first, that'd be 42. And half of 42, 21. Same answer. Now, the second triangle doesn't have the altitude, or the height, I should say, inside the triangle. It's kind of like that parallelogram picture that I showed you already, where they have, this is the height, and it is perpendicular. They had to extend the base out so that you could see that it was actually perpendicular. But I can't, in this kind of a triangle, in an obtuse triangle, most of the time the height measurement is going to be outside the triangle. But you can still see how tall that is. It's the 10 meters. So for my area formula, I would have 1/2 times base times height. So 1/2 times 14 times 10. Now, again, any order you want, or just use a calculator, just type it in. By the way, I don't type in 1/2 on a calculator. I would use a 0.5, or I would divide by 2. But in my head, I can do 1/2 times 14 is 7, and 7 times 10 is going to be 70. So my area is going to be 70, and this was in meters, square meters. Trapezoids sometimes give students a little bit of an issue. This formula is a little bit more extensive than the other ones. But again, it's on your sheet, and there's different ways to write the trapezoid formula. So I'm going to stick with the way that they have it written on your formula sheet, but just know that this isn't the only way to write this, in case you've seen it other ways. Here's my formula. The h you should recognize, that's the height. In this case, it's going to be the 5, because it's the distance between the two parallel sides. Do you notice these arrowheads right here? Because they have the exact same marking. That's how we show that they are parallel. These aren't tick marks like showing they're congruent. This is showing that they're parallel. And in a trapezoid, those two sides that are parallel are called bases. The bases we're using as the A and the B in this case. So I'm going to have 1/2 times 5, and then in parentheses, I would have the 4 and the 9, or the 9 and the 4. I don't care which one's the A and which one's the B. Now, you do have to be careful with order of operations here. And again, some calculators are great with this and others are not. So you have to be really careful. I would just suggest that you just use your own brain and do your own order of operations. So inside the parentheses, 4 plus 9, that's going to be 13. And then let's just multiply by the 5, kind of working our way out. And then either multiply by 1/2 or multiply by 0.5, or like I said, I like to just divide by 2, which is the same thing as multiplying by 1/2. So my area on this one is going to be 32.5. This was measured in centimeters, so square centimeters. I want to mention something about this formula. You know you're multiplying by the 1/2. I want you to think about what you know for finding an average. To find the average of two numbers, wouldn't you just add the two numbers and then divide by 2, multiply by 1/2? Really, what happens in this formula, when I'm adding these two numbers, and I got the 13, and then I take 1/2 of that, that would give me the average of these bases. Here's what that would do. I could kind of cut off this part and move it up here to fill that in. I know I didn't draw it perfectly, I'm sorry. And I could do the same thing here. I could cut off this part and bring it up here, and it would fill that in. I can get a rectangle, but the bases are not going to be as long as the 9 and not as short as the 4. It's actually the average of those two. When I find the area of a trapezoid, I find the average of the bases. So I would add the 4 and the 9 and then divide by 2. And then I multiply that by the height because it's so similar to a rectangle formula. However, if that didn't make sense, just plug stuff into the formula. Work it through with order of operations. I'm going to move up a little bit so I have some space on this one. So the area here, let me write the formula again. It's going to be 1/2 times the height times the sum of the bases, right? Adding the two bases together. So I'll have 1/2. The height again is 5, but this time my bases are 16 and 9. So calculators, in the parentheses, 16 plus 9 would give me 25. And then if you want to just keep going, just write backwards really on this one, 25 times 5 is 125, and then multiply by 1/2 or divide by 2, which would give me 62.5. This didn't give me a label, so I would say square units, whatever that unit happened to be. These last two problems are circles. Now I really do hope that you have a calculator handy, because we like to use the pi button on calculators. If you don't have a pi button on your calculator, you can use 3.14. The pi button is a little bit more accurate, but 3.14 is pretty darn close. So my formula for the area of a circle is pi r squared. The r stands for the radius. The radius is this segment that they have drawn from the center of the circle out to the side of the circle. So in this case, the radius is 9. So I would have, just doing my substitution, pi times 9 squared. Now, think about order of operations. Don't get tricked. You cannot multiply the pi times the 9 and hit equals and then square that answer. because the pi would then also get squared. I have to make sure that I do this part first. So 9 squared is going to be 81 times pi. If you have the pi button, please use it. And actually, you guys realize that pi is not an exact number in your calculator. We can get really, really close, but it's not perfect. I'm going to use squiggly equal signs whenever I think about it when I'm doing stuff with pi. So this is going to be 254 point, let's round to 2 decimal places, 47. It was really 0.4690049. The 9 would make the 6 round up to a 7. This was in inches, so it's going to be square inches. And I know that some people are going to be like, oh, but how can it be square if it's a circle? It's still area. Okay, so 254.47 square inches. If you don't have the pi button, you can certainly use 3.14. Let me find that answer so we can see how close we are. When I used 3.14, my answer was 254.34, which is just a little bit lower, but that's okay. This last one has a little bit of a trick because they aren't giving you the radius. They're giving you the diameter. The diameter goes through the center, but it goes all the way across a circle. So in this one, this diameter of 12 centimeters is not the number that I want. Remember, my formula is pi r squared. So some people say, oh, but r squared, wouldn't that just be 6 squared is 12? But it's not, right? 6 squared is not 6 plus 6. This radius would be 6. So I would have that area equals pi times 6 squared, which is 36. So I would need 36 times pi, which is going to give me, squiggly equal sign, 113 point. Now, here's my problem. I've got, well, there's my decimal, 097, and then some other stuff. That 7 would make the 9 round up. So what I'll really have here, I'm going to write it up here, 113.10. And then some people are going to say, but why do you need the 0, right? That doesn't do anything there. It's just to show how accurate I was. I really did round it to 2 decimal places, and I want to show that I rounded it to 2 decimal places. Square centimeters. So today, please have a calculator handy, have your formula sheet handy as you're solving for area. And if you have any questions, let me know.